So we will wait few more minutes, let others join, and after that we will start today's live interacting session. So I hope the screen is visible to all of you. Okay, so we will start today's session. So before starting today's session, let me introduce myself. I am Niloy, a PhD scholar from IIT Bhubaneswar, and this course I am your TA for this course of fluid mechanics, and this is your ninth live interacting session. And this course is been taken by the course instructor Professor Subhashish Dutta. So I hope that all of you have gone through the courses that has been taught by Professor Subhashish. Okay, so in this live interacting session, what I will do is that I will just summarize this content, what he has discussed, and after that we will go through some numerical problem, and this will help you to solve the related problem, right? So I hope this gain in the audio is here for all. Okay. So before going to through this today's live interacting session in the content. So first let me brief about this subject. So this subject fluid mechanics, it's an interdisciplinary subject. So it is basically quite essential for the student of civil engineering, mechanical and chemical. So in this subject, what you will learn is that you will learn how to solve typical problem like the control volume type problem or some real life complex scenario, say water is flowing through a channel and all such types of problem even in the jet propulsion, and all these problem which you will find in your project or in your BTech project, MTech project. So these courses will be quite beneficial for you if you go in depth with this fundamental concept, right? So what we have discussed in this last week, in the last week we have discussed about various types of flow, which include this laminar flow and the turbulent flow. Also, we have studied about these losses in this pipe fitting and how to solve this problem, and we have gone through few numerical on this. Also about this flow in this non-circular conduits and multiple path pipe flow. These are the topic that has been discussed, and the numerical correspond to this topic has been explained in the previous class. So whatever you have learned till now, please revise this thing accordingly, because each and every classes is correlated to the concept that you have studied earlier. Also, some of you may appear for this NPTEL exam. So that's why this is quite essential. If you are facing any problem related to this live interacting session, you can raise your doubt through this mic, or you can use your chat box. So I am here to solve your doubt. So let me move to this today's live interacting session. So today's interacting session is based on the fluid flow, how we will solve this differential analysis, and also this mass conservation equation. We will solve different types of problem on this mass conservation equation, right? So how I will start this session is that I will provide you a basic question, and I will give you 1 minute time and to solve you to I will give you 1 minute time to you to solve this one, and after this I will explain the fundamental concept and how to solve this question, and why all other option which option will be the correct answer, and why other option are not the correct answer, and all these things I will explain in detail. But before this I will provide you this question and give you 1 minute to solve. So this is the tempo that I will following throughout this live interacting session. Okay. So coming to my first question today. So the first question is that this equation of continuity is based on the principle of what? So these are the five options. So just I'm giving you 1 minute to think and answer. So please try to answer. So Rudronil has answered option A, that is the mass. So okay, good, Rudronil. Yes, the correct option is option A. So I will just explain detail about this question. So basically this equation of continuity, it is been derived from this, just let me open this one. It has been derived from this conservation of mass principle to a fluid flow. So we know this conservation of mass, that is mass can neither be created nor be destroyed. It's a this thing you know from your childhood, right? So that formula has been implemented here to derive this equation of continuity. Only the condition is it's for a fluid condition or the fluid flow. So what basically this law state? So this law state the rate of mass increase inside a control volume. I represent the control volume as CV must be equal to net of mass flowing into the volume. Okay. So what basically this control volume? Control volume say this is a small volume you are taking from throughout a, say I'm considering a So this is, say, let us consider this as a box, right? So and this is a small region in a domain, so which is known as control volume. So what has happened? So if some amount of mass is entering and some amount of mass is going out, say if m1 mass is coming and m2 mass is, so m1 mass is coming into the system and m2 mass is flowing out of the system, and say after this these two are not same. So in certain cases, if these two are not same, that means something is there in between which is stored. So this law state that whatever may be the summation of all these things should have to be constant. How? Say what is the, so the rate of mass increase inside the CV. So that is M3. So what is stored inside this one means that what is coming and what is going out, right? So that is the thing. So the rate of mass increase inside this control volume should be equal to whatever be the mass flowing and mass entering and mass flowing out of this system should be equal. So that is the law. Okay. In certain cases, say if there is no mass accumulation, then in that case it is zero. So what I can say that whatever mass entering and mass going out, it should be equal. So that is the fundamental. So this is the equation of continuity. So it should be mass. And why not energy or momentum? If someone asks you about this energy equation and from where it derives, so it basically, this energy equation is basically this first law of thermodynamics. So if I write energy equation, basically the first law of thermodynamics. Okay, and also it is the basis of which equation you have studied in the earlier classes, which is the Bernoulli's equation, right? Next is the conservation of momentum equation. So this is basically this Newton's second law. You have studied this law. What this law states? So basically this law states that the rate of change of momentum is directly proportional to this applied force, and the change take place in the direction in which the force acts. So basically this is the same concept that has been implemented for this fluid. So we have to summarize the net flow, the net momentum should be equal, and it's the basis should be equal to the action force applied. So this is the basis of this Navier-Stokes equation, or even it's for the Eulerian equation. So it is not this. So this continuity equation is the principle of conservation for only mass. Okay, so good. So next I am moving to this next question. So in this question, it has been asked that for a to the incompressible flow, the slope of the equistream can be given as what? So basically, today's class is a recap of what you have studied in the earlier class. So please try to answer this one. Think and answer. I am giving you 1 minute time. So please try to answer. So what you will answer with the option A. Okay, let us see if it's correct or not. So see, in case of fluid, what we know that for any 2D flow, for any 2D flow field, this V is a function of small u and v, where this u is the velocity component in the x direction, and say this is the x direction and this is the y direction. So if a particle is moving in the x direction, we consider this velocity as small u, and if it is moving in the y direction, we consider its velocity as small v. Okay, so now we have to know this definition of this streamline. Basically, a streamline is defined, it's a curve that is just tangential to the velocity vector, right? So always remember this thing. If you know this velocity field or this velocity vector, overall velocity vector, if you find out its tangent, then it is the streamline. So basically, if I found out this slope, tangent means I can find out this slope. So what is the slope? I know that slope is dy dx, right? So this dy dx, see, dy means the small change in the y direction. So this correspond to the small change. What is there? There is a velocity small v, and corresponds to the small change in x direction. There is velocity u. So I can write dy dx is v by u. So that is the thing has been asked in this question. Find the slope. So which is v by u? So the correct option is option A. I think you understand this thing. This is just the formula of slope, which is dy by dx, dy dx. So corresponds to y, as in the y direction there is only, but why it is v and not, actually I just assume a case. Say a particle is initially at this point it is 0, and after moving something it is gaining a velocity v. So dy is the change in this distance. So corresponding change in the velocity, say v minus 0, which is v. Same in the x direction, it is 0, and corresponding it is u. So with respect to 0, the change is u minus 0, which is also u. That's why this is v by u. Okay. So I am moving to this next question. So it's a numerical question where it has been given that for a steady flow of a gas at 100 mm section of a pipe, the density is given and the velocity is also given. And in another section 150 mm, so here this velocity is given. So you are asked to find the density of the gas. That means at the section having diameter of 150 mm. So that is the question. So I am giving you 2 minutes time to solve this one, as it's a numerical one. You can use your calculator. So please try to solve. Please try to answer. So, so I'm giving you 30 more seconds. Please try to answer. So you said that your answer is not matching. Okay, let us check. So basically, here what it is said that for steady and incompressible flow, right? So for steady and incompressible, why I said incompressible, not no information is given, so we can consider even gas is not that as no condition is given, so we can consider it as incompressible. Sorry. So for steady flow, not compressible, incompressible. For steady flow, what we know that whatever with the mass entering into the system, there should be equal to the mass going out of the system, right? So that means mass entering means rho 1 A1 B1, that is the mass entering, and mass going out is the rho 2 A2 B2. So here the thing is that first the pipe is of small diameter, and after that its diameter increases to this much, right? So see here area is less, here this area is more. This is A2, this is A1. So also as the diameter is given, so I can write A1 is pi by 4 D1 square. So here D1 is given as 100 mm, that means 0.1 meter. So I can write pi by 4 into 0.1 square. Again A2 is pi by 4 D2 square, which is 150. That means pi by 4 into 0.15 square, right? So accordingly I can write, say what I need to find out rho 2. So this rho 2 is rho 1, I kept it same, A1 by A2, B1 by B2. So that is quite simple in this scenario. So this rho 1 is 2.5 already given. A1 by A2 means this is zero point 0.1 by 0.15 both whole square, and B1 is, whether B1 is given, yes, B1 is 10 and B2 is 6. So now I have to calculate this value. Let us check. You also calculate. Let me calculate. This is 210.1.15 square into, what is that, 10 by 6. So the option answer that is coming here is rho 2 is 1.85 kg per meters cube. So that is the correct option. So the correct option is option C. So I hope that you understand the mistake, Mr. Patel. So please check whether you understand this mistake. Okay. So now I am moving to this next question. So it's a theoretical question regarding the stream function and incompressible flow. So just check which of these one will be the correct one. I am again giving you 1 minute time. Okay. Okay. I think you are not aware of this concept. Okay, let me solve this one for you. So I will just brief you a detail about this concept. So what this thing indicates, and basically if we talk about this concept of the stream function, always remember this. If we talk about the stream function, is basically for a 2D incompressible flow. Not exactly 2D, it can be for a 3D incompressible flow. But as in the question, it is mentioned that it is in a 2D incompressible flow. So, in case of 2D incompressible flow, this stream function is retrieved psi as a function of x and y. So here these velocity component are derived from this psi. Okay. So and also this, if I talk about, it's a stream function. So what is streamline? Streamline basically are some lines which represent the constant value of the psi, are contours or lines of constant psi. Okay. So that is the identification of a streamline. So basically these functions is not for a compressible flow. It it is not fully defined for a compressible flow. It is for an incompressible flow. So generally it for an incompressible. Maybe sometime it for a compressible flow. So this option, so this first option is not the correct option, right? Okay. So next is the stream function is a constant along the streamline. Yes, what I have said is the definition of a streamline. So next is the stream function can be used to determine the pressure directly. So basically it do not give the pressure directly. So what it gives us to find the velocity component, and also it is giving a value at a constant particular value, right? So it will not help us to determine the pressure directly. The streamline is undefined at a stagnation point. No, it is defined at a stagnation point. Why? Because as it is a constant psi, so at any point you will find this value of streamline is a constant. So that is also not a correct option. That's why option B is the correct option here. Okay. So I am moving to this next question. I hope you understand. This is another theoretical concept. So please try to solve this one. I am again giving you few minutes time to solve this one. So please try to solve this one. So either you will be able to solve this one, or I will have to solve this one for you. So please let me know as I start this. Okay, so no issue, Rudranit. So I will explain the detail for you here. Okay. So let us go through this concept. So for this concept, you need to know this one of this fundamental of this momentum equation. Sorry, continuity equation. Not this continu. Sorry, momentum equation, not continuity equation. So it's basically what this equation state. This equation state that density is an acceleration should equal to be the gradient of stress tensor. Okay, so that is the this is also known as. So if in any question you need to find out this acceleration and this stress tensor component stress or stress component is given, you have to apply this Cauchy momentum equation. So I will simplify this equation for you. So in this equation, no body force is considered. What is not considered? No body force. That means no rho g term is there. So only the acceleration component. This is the density into acceleration. That means this acceleration inertia term. So this inertia term should be equal to this divergence of stress tensor. This is known as divergence tensor. So if I summarize or simplify this one, say it is for x direction. So it's a vector. I also take only x. So what this is basically represent this is this del. Okay, sorry. This del means this is I cap plus, sorry, this is j cap, this is k cap, this is del, and scalar product of y. So it should be so many component, as it's an x, so it should be only x component, right? I cap plus j cap plus del x z k cap. Okay, so if I dot product it, what I will get? This is I x x plus dou dou y of sigma xy plus dou dou z of sigma xj. So this is our final formula of acceleration, right? Okay, in this question, what has been given? So this has been the acceleration here. So you understand this fundamental. Up to this fundamental, I hope that it is clear. Now, in this question, what is given? Psi xx is given by sigma yy is given 10 and sigma zz is given 15, right? So only in the y direction, you just see here this component is not given, right? Okay, so I can consider this as 0. Also this component is not given, so I can consider this as also 0, right? Okay, so here from there I can write ax is dou x of sigma xx by rho. Is it? You got my point? So here one thing, say only this value of this one is given. So no information is given about this thing, right? So either sigma xy. So this sigma xy is the net force per unit volume in the x direction. So I consider this change in the x direction as 1, as nothing is given. So that means I can directly write here as 5. So because this small change, let us consider this small change is not, that means here only for this change in 1 unit, this del x's is 5. So I can write this as 2 also rho. So that is 2.5. So this correct option is option A. I think you understand this concept, right? Okay. So I am moving to this next one. So this is another theoretical question. So here this physical significance of this mass conservation equation in a compressible flow, what it basically represents, this is the question. So this is the four option. The first is the velocity remain constant, next is the density remain constant. See, this mass flow rate changes with time, and this mass flow rate remain constant throughout this control volume. These are the four options. So please try to attempt. I am giving you 1 to 2 minutes. So Rohit has answered option D. Okay. So let us check this one. So I am explaining this thing in a little detail for you. So basically, this continuity equation, if I talk about this continuity equation, so what it states, I can write accumulation of mass. So I'm talking about a control volume. Say in this control volume, whatever with the mass accumulate, and this should be equal to the net mass in inflow, or I can write this plus net mass outflow. Okay, should be 0. And that means either you can write accumulation of mass in the control volume should be equal to net mass inflow into the system, or it should be net mass outflow into the system. So if in general term what I write, say you remember, I think you remember this thing. This is M1, this is M2 dot. What I have written earlier, this is M3 dot, this equal to M1 dot minus M2 dot. And the this is the net mass inflow, and for outflow it is M2 minus M1. Okay, so that is the basic difference. So in generalist term, I can write accumulation of mass can be written as, so change in the density per unit time. So whatever with the change, that should be accumulated only. So if certain thing is flowing through any volume, if it is accumulating there, that means it is accumulating with respect to time. So that's why it is dou rho by dou dot dou t plus net mass flow. That means it should be gradient of rho v, right? So here this first term, what this first term indicate? If I talk about this term, in its physical significance, if I talk about, it is the local rate of change of density. Okay. And if I talk about the second term, so what this indicate? This indicate the divergence of mass flux. Divergence of mass flux here, basically it gives you the condition whether the mass is, whether this mass is outflowing from this system or ingoing in this system. It's the total or the summation of this. Say if I take a certain scenario, say if 2 kg is entering this system and 3 kg is entering the system and 2 kg is outflowing from this system. So what would be the next? 3 minus 2, that is 1. So that is the net mass outflow should be 1, and that means minus 1, not 1, it should be minus 1. That means 1, this one amount whatever is remaining, that should be removed in order to maintain this condition. Okay, this is divergence of mass flux. Okay, again if I talk about steady flow, Steady flow means the change with respect to time should be zero. So I can write, so that's why in the previous one you remember that whatever is entering into the system and whatever is coming out of the system, there should be equal. So that is because we have considered it as a steady flow. That's why in case of steady flow, this is the final form of this continuity equation. So that basically means mass flow rate inside and in and out should be equal. Should be equal to mass rate outgoing. Okay. So that is the fundamental here. So which will be the correct option? So this is your mass conservation equation in a compressible flow. So in a compressible flow they are talking about. So that means rho can change. Okay. So this density, this will not be the option. Say the velocity remain constant. So we can't say anything about this velocity. Also about this density is not constant because it is compressible flow. The mass flow rate changes with time. So if the mass flow rate changes with, that is a impartial statement. So we can't say anything right now. Again, the last option is the mass flow rate remain constant throughout this control volume. Yes, if at a certain volume, say why, if I take this section and this section, whatever the total of the mass flux in this region and mass flux in this region, that should be equal. So the correct option is option D. Okay, got my point? I hope so. So I am moving to this next one, right? You understand this thing? I hope so. Okay, I am moving to this next question. So here, a fluid element in a stress field having a normal stress is given. So what is the mean normal stress? It's a very simple question. I hope that you can easily answer it in 1 minute. So please try to answer. So you didn't- just give me 1 minute. Okay, so Rudunil has answered this question. Let me check what he have answered. So he has answered option B. Yes. So basically, this mean normal stress, which is also this hydrostatic stress, is basically this summation of stress, average of summation of stress in three direction. Say if it is x, it is y, and it is z. So if I talk about this mean, always it is the same mathematics that in the x direction plus whatever should be in the y direction plus there should be divided by 3. Okay, so that is 10 plus 15 plus 20 by 3, which is 45 by 3, that is 15. So this correct option is option B. It's the correct option. Good. Rudunil, you have answered it correctly. So now I am moving to this next question, right? Okay. So in this question, it's a two-dimensional flow. The equation of the streamline is what? So these are the option. So I am giving you 1 to 2 minutes to solve this one also. So please try to solve. So please try to answer quickly. Okay, Rudunil has answered option B. Okay, let us check what exactly will be the answer. So what I though about the streamline, what I have explained earlier is that say for a 2D flow fluid. Okay. So how I can represent the velocity? So this velocity is represented as u by v, right? I am just recapping this thing for you. So if it's in x, it's in y direction. Okay. So a particle is there. So its x direction velocity is u and y direction velocity is v. So that's why this capital V, which is a flow field, it should be a function of u and v. So here u is the velocity component in the x direction and y is the velocity component in the y direction. Sorry, v is the velocity component in the y direction. So now coming to this definition of the streamline, what exactly it is? It is a curve, right? Streamline basically is a curve where it is tangent to the, I can write as it is tangential to the velocity vector, to the velocity vector. So that means directly if I find tangential means there is some discussion about this slope. So if I talk about this slope, I can write dy dx. If the slope is quite small, this is infinitely small, that I can also write as like that way. Yes. So basically, this is the change in the y direction, which is v minus a0. So this small change I can represent it as v by u, right? So if I rearrange this thing, what I will get, dy by v is dou y by v is dou x by u. So any option that matches with this one, dou y by u. So first option is not correct. Next is dou x by u and dou y by v. So option B is correct. Next is v by dou x. No. If it is v by dou y, then it can be correct. So it is also not correct and it is also not correct. So option B is the correct option. Okay, so basically is the definition of the streamline, which is that a streamline is defined as a curve that is everywhere tangential to this velocity vector. So correspond to this definition, we can easily solve these types of simple question, right? I hope that you understand this thing. Okay, now I am moving to this next question. Okay, so this is another question. So in this question it is asked this continuity equation this is valid for what? So these are the four options. So I am giving you 1 to 2 minutes to solve this one. So please try to solve. So see up to this question, up to this first 8 question, do you have any confusion or you understand everything? Please let me know. So I hope you do not have any doubt. If you have any doubt, please raise your concern through this chat box. So, okay, thanks for the confirmation. So, as it is clear to you, so please try to answer this question. So, this question is basically on this continuity equation and where and how is this equation valid. So, this is definitely an equation that need to be valid for a certain scenario. So, already I have discussed about this thing, so I hope that you would be able to answer this one. So, please try to answer. I'm just giving you 1 more minute to think about this one. So, I think you are not confident about this question. Okay, still you have attempted. So, your answer is option C. Okay, let us check. So, no, it's not option C, it's option B. Why? Let me again recap this thing for you. So from this continuity equation, you remember most probably 2 to 3 slides earlier, the thing that I have discussed is that rate of mass accumulation, you remember? Rate of mass accumulation plus net mass outflow. There should be zero. So if I represent it in generalized terms, so it should be dou rho dou t plus gradient of density into velocity 0. So this is only velocity component. And that means this component should be 0. When will be this component 0? If I consider steady, that means change with respect to time, there should be 0. So this equation, the above equation can be simplified to this form. So where both these two are variable, if in the question it is said that rho is constant, rho is constant means incompressible. If it is incompressible, now I can take out this rho outside this operation, del operation. So that means this V rho is gone. So that means what I will get, and changing the color, gradient of V is 0. What, sorry, divergence of divergence means I have already discussed about this. Divergence is this one, del, sorry, j cap plus k cap. This is del. And dot product of v. So what is v? V is a vector. So if it is in three directions, so that means u I cap, u is in the x direction, v j cap, it is in z direction, plus w k cap. So if the dot product I should be dotted with this one. So accordingly, what I will get, this should be equal to 0. Accordingly, I will get dou u dou x plus dou v dou y plus dou w dou z. This is equal to 0. So this is the final equation. So that is option B. So this option B is the correct option. Okay, you understand this thing? So I hope that I hope that Rudunil you understand this mistake. So I am now moving to this. Can I move to this next question? Okay, I'm moving to this next question. So please try to answer this question. It's about this Navier-Stokes equation. So which is also known as this momentum equation. So please try to answer this one. So please try to answer this one. I hope that you are not able to answer this question. So let me solve this one for you. Okay. So to start this, let me brief small about this thing. So what basically this Navier-Stokes equation is? So this Navier-Stokes equation, so I represent this Navier-Stokes as NS equation. Okay. So it basically balance few forces. What are these force? Inertia, pressure, viscous, and body force. Body force terms. So that are the terms which has been used in this Navier-Stokes equation. Okay. Now, in terms of a vector form, this Navier-Stokes equation can be written as, so it's this equation you need to remember sometimes. So this is another equation. So basically this is tau, right? This tau in place of tau, so there is some generalized formula. So forget about this. So first, why this equation is non-linear? So this equation is non-linear because of this presence of this term. So this term is not non-linear. So why? Say this V dot del V. So basically it's a compact representation of this thing U into du dx plus V, when I am talking about only this x direction deviation. So this is for x momentum equation I am writing. Okay. W du dz. So here what it is it involves the product of this velocity component and their derivative, right? So you can easily see that non-linear interaction is there, though in the first term u and u is there. Here is the velocity of x direction plus change in the y direction. So there is no such linear pattern, non-linearity is there. Also you see derivative term and the individual terms is there. So and overall combinedly all these factors contribute to its non-linearity. So it's a non-linear equation that is correct. Next is the unsteady. See, in the generally, if nothing is said, then it is changing with respect to time. So definitely it will be an unsteady. So option A and B are correct. Next is the partial differential equation. Yes, it's a partial because see these terms are in partial form. Also these terms are in partial form. So all the three options are correct. So I can say option D is the correct option. Okay, so this is the basic. So this tau has certain formula. So I cannot recall this formula right now. So if you this is stress tensor. This stress tensor, viscous stress tensor has a specific formula in terms of mu and all these things. Okay, so like say what we know, what is tau? Tau is mu into du by dy, which is this one. So if you put it here, it will be converted into mu, this types of thing. So using all these things, you will be able to solve this. So this is a complex equation and it's a combination of the nonlinear, unsteady, the partial differential equation. So that is our, our correct option is option D. Also, why this partial differential equation? So this partial differential equation, why, how this help? Because this solution is quite essential because we know certain boundary conditions. Say at time t equal to 0, the velocity is this much, or a certain wall is at adiabatic condition like that. Considering all these things, we can say that the partial differential form of the Navier-Stokes equation is quite essential for solving such types of problem. Okay, so this is our, so and after that, say if I talk about this equation in a generalized way, so sometime you have been asked to simplify this equation. If it is a steady condition, so then this term should be 0. And if it is incompressible, then this row will be easily coming out, right? So in some question it is said that this velocity in this x direction, it is only in two direction and w is 0. So you can take this as 0. Accordingly, this equation will be simplified into shorter form. So it's a advice from my side to remember this equation because it will help you to answer a lot of questions. Okay, sometime in a question it will be said that the viscosity is 0. That means this term should be 0. Like certain types of thing can be asked, so you have to prepare accordingly. So nothing can not be tell about this thing. So now I am moving to this next one. Okay, this next question. So it's a question on the stream function, where the stream function is given and the magnitude of the velocity you need to find out. So I'm giving you 2 minutes, 2 to 3 minute time to solve this one. Let's try. So whether you will be able to answer this one. So just I'm giving you a hint. So as the stream function is given, you can find out this u and v, right? So what is u? U is the derivative of the stream function with respect to y. That is opposite here. Potential function, for potential function it is with respect to x, but for stream function it is opposite. Whereas if I talk about this v, it should be the negative derivative with respect to x, opposite. Okay. Yes. So you have answered option B. So see, whatever you have answered, let us check whether it is correct or not. So the stream function in this question, this stream function is given. This stream function is 2xy. So we know this u is the derivative of this partial derivative of this stream function with respect to y. So that means 2xy. So 2x would be constant and derivative of y is 1. Similarly, if I talk about this b, it is negative derivative of 2xy, which is minus 2y. So the point is given 3 and 4. So 3 and 4 means here x is 3, y is 4, right? So in place of x, if I put 3, it should be 6. And in place of y, if I put my 4, it should be minus 8. Okay. So I get u and v, but the magnitude of velocity is given. So the overall velocity is the derivative is the integration of this one, or the derivative of this one. So which is 6 square plus, okay, this is 64, which is 100. So the correct option is option B. So sorry, I just so Rudunil, please, Rudunil, your answer is correct. It is option B, 10. Okay, so this is the way you have to solve certain types of question. So first, you just have to remember this thing, nothing else. So you need to recall this thing, and everything else you will be able to solve. So this is how you will solve these types of question. Okay. So I hope that you understand this question. Now I am moving to this next one, right? So this is the question. In this question, again it's a question of streamline where a point is given and the velocity function is given. So this equation of streamline you need to find out. That means the equation of the curve. So streamline is basically a curve where the tangent or the slope of the where this tangent is parallel to where is this where sorry, this streamline is a curve where this is tangent to this velocity function. So that is the function and that is the fundamental. So you can easily find out this one. Please try to solve this. because for this one you need nothing else, you just need the velocity vector, the streamline. You need to know what is the basic formula of the streamline, and accordingly using integration and all these things you will be able to solve this one. So please try to solve this one. I'm giving you 3 minute time. So whether you will be able to solve this one, please let me know. Okay, I'll wait 1 more minute and after that I'll solve this one. Okay, I am solving this one for you. So, so here this v is given, right? Velocity vector is given. So this velocity correspond to this velocity vector. So this u is here minus y square, because we know that v is a function of u comma v small v. So similarly, this small v is minus 6x. So we got this thing. So as it's a streamline, so in this question it is already given that it's a streamline, right? So what I know in the streamline, that means it should be derivative, its slope should be the b perpendicular, sorry, this streamline is everywhere tangent to this velocity vector. So that's why I can correspondingly write this as a v by u. That means it is tangent or the tangent to this velocity vector. So accordingly I can write this thing. So what is v here? V is minus 6x and this one is minus y square. So this minus will be cancelled out, and if I take y square inside of dy, and here this one, right? I can write. Now if I integrate both sides, so what I will get? I will get this as y cube by 3, this equal to 6 x square by 2 plus c, right? So also if I fully summarize this thing, this can be written as y cube equal to 9 x square plus 3c. Okay. So what is the initial condition here? The initial condition is 1 comma 1. So that means here x is 1 and y is 1. So correspondingly I can write this as, is it 1 plus 9? Okay. So the c here is minus 8 by 3. So what I will get, eventually I will get this as y cube equal to 9x square minus 8, because c is minus 8 by 3, so 3 will be cancelling out. So, or I can write 9x square minus y cube, this is 8. So this will be our correct option. So option A will be our correct option. So this question is quite important. Certain types of question you can expect to come in the question. So please go through this question properly. I hope that you understand this question. Okay. So now I am moving to the next question. So it's a tricky question. So where it has been said that a 2D incompressible flow is taught about and it's a streamline function and this value is given. So also the point is given. So you are asked to find this velocity component ur. The r should be in suffix here. Ur, that means u suffix r and u suffix theta. So that thing you need to find out. Okay. So I am giving you an again 2 minute time for this one, and after that I will solve this for you. So I hope that okay, just I'm giving you hint because this polar coordinate concept you haven't studied right now. So see, in case of Cartesian, what we know that this u is the u. We normally say this u is dou psi by dou y, and in for v this is minus dou psi by dou x. But in case of Cartesian, this r will come first. So accordingly, this formula should be like this one, right? By dou r, but it is not like that. So for r, it should be with respect to theta. Still, there is 1 by r in the front side. This is for polar coordinate. And for u theta, this should be same. Minus r. So as it is theta, so the derivative would be with respect to the opposite one. So this thing is given just derivative this thing and you will get the answer. So please try to solve. So use this formula. So nothing else is required here. Just the pi is required. You got this thing here from here. This psi is here. So accordingly you can find ur and u theta. You solve this one. So you are saying option A. Okay, let us check the solution. So see here this psi is log r by r. So that thing for simplification I can write ln like this way. So see here there is no theta term. So if I derivative this with respect to theta it should be 0, right? And with respect to r, so it should be 1 by r minus this r is constant so it should be 0. That is minus 1 by r. So here a velocity magnitude are been asked to find. So this v is u r square plus u theta square. So that is 0 square plus minus 1 by r will be the answer. But a point is given where x and y is r by 2. That means x is r by 2. Okay. So just a minute, let me check this thing. So at this point x comma this is given. So x comma y gives, so r means already in this question r is given as x square plus y square. So we need to find r. So that is, this point is r by 2 square plus r root 3 by 2 square. So r square by 4, 3r square by 4. That means it is should be r. So therefore the correct answer should be 1 by r, because at x comma y corresponds to x comma y, the small r is capital R, as we got from here. So this correct option is option A, that is 1 by r. You understand this concept? So what we did initially, we found out this polar, through this polar concept we found out this u theta and ur, and that means the velocity in the polar direction we have found out. So and accordingly this velocity magnitude is found, which is 1 by r. Now the point is given in terms of x and y, that is Cartesian, not in the polar. So convert this Cartesian into polar. So already it is given in this question that to convert this Cartesian into polar, we have to use this formula, which is r equal to root over x square plus y square. So I have put this thing here and I am getting this value of small r. So we have to put this value of small r in this v, and accordingly I get this answer as 1 by r. So that's why this is the correct answer. So I am moving to this next question. So two more question for today. So I am just giving you 1 minute time because it's a simple 1 to 2 minute time because it's a simple question. You can easily answer this one. So the v is given, the coordinate is given, time is also given, just it has been asked to find this value of b. So the three component you need to find out, and correspondingly you can find out this magnitude. So please try to solve this one. So please answer. So you have answered option B. So let us check. So what is given? This is xyz. That means this term is your u. This is your v. This is your w. So I'm writing this thing. This u is 6 xy square plus t. Okay, and this v is 3z plus 10. This w is a constant which is already 10. So now this point is given. This x, y, z and t is given. So I can put here in place of x I can put 10, In place of y, I can put 1 square. In place of t, I can plus 5. So that means here 60 plus 5. So I got this corresponding value of u. Similarly, I can find out this value of v. Here this z is 2 plus 10. So 6, the corresponding value is 16 and w is 10. So these are this value. This is the component in the x direction, y direction and z direction. But I have to find out the overall magnitude of velocity, which is root over u square plus v square plus w square. So which is 65 square plus 16 square plus 10 square. So if you calculate, you will get value around 67.68 meter per second. So that's why option B is the correct answer here. Okay. So this is simple question. I hope that you understand. You have already answered it correctly. So now this is the last question for today. So please try to solve this one. So here also it's a problem related to the streamline function where a 2D incompressible flow, that means density is constant, are given. So you are asked to find this V component. It's a quite simple question. I think 1 minute is more than sufficient for this one. Please try to solve this one. So it's like the previous few questions. You just have to remember how to find out this velocity component from a stream function, and also remember for this potential function. Though potential function has not been has not been discussed in the today's live interacting session, but I have already discussed this in the earlier session. So please go through this session. So this video lecture correspond to this session has been already uploaded in this corresponding link which has been provided by this NPTEL through your mail. So please go through this concept, and if you have any issue, I hope majority of the issue can be solved through, if you go through this video. And also if you found any issue or any doubt, so raise this concern through this feedback form, or you can just mail to me regarding your problem or doubts, and I will be there to solve this thing. So now as this is the last question, so you know what is the concept that is required to solve here? Yes, I hope you will be able to solve this one. So you have already answered option A. So let us check this one. So what is given? This streamline function is given. So what do we know? If a streamline function is given, this u is the derivative with respect to y, whereas this v is the negative derivative with respect to x, right? So that is the thing. So v we need to found out. So I can write here this derivative with respect to minus ax cube plus by square plus cy, right? So now it's a partial derivative. So minus a will come out, and this will be 3x square, and this is constant because no x term is there. And yes, so accordingly, so what I will get, this is 3ax square. So the correct option is option A. So good, Rudunil, you have answered it correctly. So you have attempted most of the question in a good fashion, and thank you for attending this session. So if you, again, I am saying that this lecture or the notes will be uploaded in through a link which has been shared with you from the NPTEL site. So please go through these notes, and this will definitely help you to solve your assignment that has been given in this class. Okay. So I hope that you enjoy this session. We will meet again in the next week's session. Till then, bye.